Alright guys, so just want to talk one or two points about today's video. Alright, I recorded it basically capturing the screen. Now, I've been talking away, pointing with the mouse, and for whatever reason the screen grab didn't record the mouse movements. So I've been going around the whole, for this video, pointing at various stuff as I'm talking about it. That has been picked up, it hasn't been recorded. So you're there listening to me talk and you're wondering what the hell is he on about or where is he? So just start the question at the start and work through, and you kind of follow it that way, right? So there is a bit of it there that you're wondering what am I doing, but basically mouse pointer isn't being picked up, it isn't being recorded. Point two, I probably won't do a video again like this the same way as I've done this one because it is very long. Like the video is, I think it's about an hour in length. Now I know, I suppose there's a few questions in it, but like an hour, I'm not going to expect you to take and sit down and watch an hour, right? If you struggle with any of the questions there, look over them, just don't zoom, skip on to the video to whatever you need to. All right. Um, so mouse not working, long video. All right. As well as that, I'm not sure it was recorded via the mic on the laptop, so I'm not sure how clear my voice is coming out. It's coming a lot better through the phone. So right, as I said, probably won't do one of these videos this way again. It's a lot quicker just to do it up on the board, even if I don't have the question in front of me, if I have to keep chopping and changing between the book. Alright, point three, just on your homework itself. Alright, thanks to those who have handed it up. There's 4 of you. I won't call out your names here. You know who you are. I was wrote up in the Google Classroom. Right, if I don't get homework from you, I've no choice but to take it, contact the school will contact home, and then you're on bother. Alright? So you're putting work on me, you're putting work on the school, and that won't be referenced nicely when we have to contact home. So get the work turned in as you're meant to have it done. Alright? You've plenty of time to be sitting on your backsides doing nothing. Take and do what you're asked to do. Thanks. Okay, go on in class. So today we're going to do things a little bit differently in that we're going to be looking at exam papers. So that's why we're going to do a video recorded through our screen. All right. So the homework exercise started off there was the higher level paper to 2019 question 7. Now we've already this done in class, but we skipped the section on trigonometry because we hadn't done it at that stage, so we're going to come back to it now today with a little bit more focus. But just as a recap, we're going to work through this question 7 from start to finish, and we'll move on from there. All right, so question 7 there. A triangle has one side of length 10 centimeters and another side marked X. The perimeter of the triangle is 26 centimeters. We need to find out the length of the third side in each of the cases. All right, so we have 10 here, we have 4. Adding those, you get 14. If the whole perimeter is 26, well, 26 minus 14 is going to give us 12. All right, so we're going to have a side for the third side there of 12 centimeters. All right, if we look now at diagram B, we have 10 and 9 is 19. 19 from 26 is going to give us 7. So we're going to have 7 centimeters of a side. All right. A, nice and easy. All right. B, now find the length of the values of X to make the triangle an isosceles triangle. So an isosceles triangle is what? The triangle where two angles are the same in measure and also two sides are the same length in measure. So keeping our 10 centimeters as our base, all right, we need to also stipulate the 26 perimeter. All right, so 10 from 26 is going to give us 16. Half of 16 is going to give us 8. So we can have one side of length 8. Okay, so 8 and 8 is 16 and 10, 26. All right, that's side 1. If we want then to have another side the same length as 10, so we're going to have 10, 10, and 6. So another side here is length 10. was a little bit slow putting in tick boxes and all the like. Alright, so 8 and 8, isosceles triangle 10 and 10. Alright, or if this is our 10 and 10, that's going to give us 20, then the remainder is 6 here. So our final side will be of length 6 centimeters. Alright, so A and B, again, there's nothing hugely difficult in those, and that is that paper or page done. Alright, moving on to part C. So the graph below shows the area of a triangle for all values of x between 3 and 13. And point A is marked alongside it, and so we're then asked to work out the estimate the area of the triangle from diagram A. Alright, well, if we look along the x-axis of our grid here, it's the length of x in centimeters, and area is along our y-axis. So all we're going to do is draw a straight line, alright, from A. So imagine from 4 all the way up to A is a straight vertical line. We're just going to, from A, come with a straight horizontal line and read off of the side axis there, on the y-axis, as to where that actually cuts your y-axis. And we're going to estimate that point there is going to give us, move that up a little bit, is about 19 millimeters. Alright, you could say maybe 18.5 if you want. Right, but roughly between 18.5 and 19. Okay, so from x is equal to 9, we've drawn a vertical line up, and that has cut our curve here. And simply then what we have to do is we have to put in and label our point B. So we're just going to put in a point there and label then that point B. Okay, so there is our point B labeled, and that's all I have to do. Part 2, plot the point B on the graph. There's point B plot on the graph and label it. So second or third part here, the graph is symmetrical. Draw the axis of symmetry on the graph and the diagram above, and write the equation of the axis of symmetry. Alright, so symmetry, what does symmetry mean? It means one side is equal to the other side. So we want to draw in vertical line. So imagining basically that we have the likes of a book. Alright, so the center spine of your book, once you open a page, the left page is exactly the same as the right, so it's symmetrical from left and right. So if we look here, from 3 to 13 is 10 units. Alright, halfway through that will be 5. So 5 and 3 is 8. So if we put in a vertical line through 8, we'll just change that color there and make it a little bit bigger. So that orange line there now is your axis of symmetry. Alright, so along that line there, imagine if you were to, with a scissors, cut through that orange line, fold the left to the right, it's exactly the same. So anything on the left is mirrored on the right. Alright, or if a point here A you brought through at 90 degrees to that axis line, you would find it would be the same distance out here on the right hand side. So that there is our line of symmetry. And write down the equation of that line of symmetry. So if we look at, well, I imagine there's a point anywhere on that line. So we'll just take this point here, right, on the x-axis. What are the coordinates of that point? Or what is the value of x? Well, it is 8. What is the value of x? Anywhere along that line, it's also going to be 8. So the equation of that line then is x is equal to 8. Alright, so that's C done. Now we're going to move on here to part D and E. So D, when x is equal to 5, the triangle has sides of length 10 centimeters, 5 centimeters, and 11 centimeters. Show that this is not a right angled triangle. Okay, so First of all, we need to realize a right angle triangle. How do we prove, or what, do we know any calculations or any formula or something in relation to a right angle triangle? Well, we do. We know about Pythagoras. And Pythagoras states that the hypotenuse, if we square its length, that will be equal to the sum of the other two sides to be squared. And from your study of triangles and trigonometry, you realize that the longest side in your triangle is always the hypotenuse. All right, so the 11. So what we're going to do is we're going to come across here. So we have 11, and if we square that hypotenuse, all right, so the hypotenuse squared, that measurement there will be equal to the sum of the other two sides to be squared. So it'll be 5 squared plus 10 to be squared. All right. Now, 11 squared is 121. That then is equal to 5 squared is 25 plus 100. So we're going to get 121 is equal to 125. And we can straight away see that 121 does not equal 125. So therefore, it is not a right angle triangle. Okay, so if the left hand side, if the hypotenuse squared did equal the sum of the other two sides, then it would be a right angle triangle. But because 125 is not the same as 121, then therefore this is not a right angle triangle. Part E. The diagram below shows the triangle with the biggest area. Okay, sides of 8, 8, and 10. Work out the area of this triangle and give your answer in the form of 5 to the square root of n centimeter squared, where n is an element of our natural numbers. Okay, so how do we get the area of a triangle? Suppose most of you are going to say half the base by the perpendicular height. Is there any other way that we can work it out? Well, there is. If we take and if we look at our exam papers, sorry, a log table, should I say? 1 second, I get. Sorry, yeah. So here are our log tables. Okay, so it's the section page 4 there on page area and length. And if we look at our triangle, all right, perimeter is given their area, half the base by the perpendicular height. We also have this formula, half AB sine C. So if we knew the angle of C here and you knew the length of the two sides either side of it, you can work out the area of the triangle using that formula there. All right, or we can use this formula down here. Okay, so first of all, you have A, B, and C, and they're the length of each of the three sides of your triangle. S, and you're given the value of S down here. Basically, it is the perimeter divided by 2. All right, so we're going to use this formula here. Okay, so we'll just screen that, and we'll insert it out over here. Okay, so we'll just trim this a little bit. I realize that this is a little bit slow and tedious, so you can just skip ahead if you want until I have this finished. We'll just pop that in there to the right hand side. Okay, so we're going to work at getting the area of the triangle using this bottom section here, so this formula down here. So we know that 8 and 8 is 16 and 10 is 26. So the perimeter here is 26. 26 divided by 2 is 13. So it's going to be the three measurements, all right, A, B, and C, subtracting those away from 13, multiplying the three of them by each other. All right, so I'm just going to write this in without the square root sign, just for convenience here on PowerPoint. Okay, so I'll just copy this. Okay, so we're going to have 13 in brackets, then 13 minus A, so 13 minus 10, what will we do it now? 13 minus 10 in brackets, then 13 minus, we're going to go along the side B, which is 8, brackets, open another bracket, 13 minus 8 minus 8. Alright. Now I want to keep the 13 multiplied by, I should just say, 13 minus 10 is 3. Close your bracket, open a bracket. 13 minus 8 is 5. And 13 minus 8 is also 5 again. Close your bracket. So we want to now get all of this in our calculator and square root. So square root of 13 multiplied by 3 by 5. And remember, brackets just mean multiply. So equals 5 root 39. Okay. A lot easier when you're not trying to do it on the computer. You're to do it out by hand. Okay, so here again now we have question 13 of the 2019 paper. So nice easy part for part A. Use trigonometry to work out the value of x in the diagram below and give your answer correct to 2 decimal places. So again, no matter what you do, you always start with labeling in your 3 sides. Okay, so obviously with your A then is your adjacent, alright, which is the x. So say you're silly old Harry, old herring, trawling off America. So we want to find x, which is our adjacent. We have our O, we don't know what h is. So silly old Harry, that won't work. Caught a herring, that won't work. Trawling off America. Okay, so that is what we want. All right, so we're going to have to use tan of the angle. Okay, so don't heed the 3 over 2 for the time being. So we're going to go tan of the angle, which is 20 degrees. Tan of 20 degrees is equal to, putting in our values, tan trawling off, so it's 6 all over x. All right, so 6 all over x. Now, we want to take and get the value of x. So we're going to have to multiply x by both sides. So I'm going to get x here is multiplied by the tan of 20 degrees, and that is equal to 6. All right. So again, we're not finished here. We still need to figure out what x is. So x is multiplied by the tan. So we're going to divide both sides by the tan of 20 degrees. So our next line down, we're going to divide both sides by the tan of 20, multiplying and dividing by the same number cancel. So we're just going to get x here is equal to 6 divided by the tan of 20 degrees. And we're going to then just, via our calculator, we're going to work that out. All right, so 6 on the top of our fraction. So 6 divided by the tan of 20 degrees. So sugar. Close the bracket. Close the bracket down here. And that's going to give us, and we want it to the 2 decimal places. So we're going to leave it here at 16.48. Okay, so just recapping over this again. Okay, so what we'll do, first of all, we want to label the 3 sides. So the side opposite our hypotenuse, or the opposite of 90 degrees angle, should I say, is always our hypotenuse. We look at an angle in question, 20 degrees. The side across from that is our opposite. All right, so 6 there, the opposite. And then we also have our adjacent. All right, so we want to look at which of our 3 of our trig ratios, sine, cos, or tan, has our O and our A. Well, it is tan, trawling off America. So it is tan of the angle of 20 degrees is equal to trawling off O, which is 6, all over A, which is x. So it is 6 all over x. cross multiplying, or we're not cross multiplying, but multiplying both sides there by x, we're going to get x multiplied by the tan of 20, multiplying and dividing by x, cancel each other out, and that's equal to 6. Dividing both sides by the tan of 20, left hand side multiplying and dividing by the same number cancels, so you're just left with x, and that is equal to 6 divided by your 20, and that simplifies down to be 16.4848, whatever it is. Okay, and that then to two decimal places is 16.48. Okay, right. Part B. A different right angle triangle is shown on the right. It has the sides of length A, B, and C, and one of the angles is marked Y. In this triangle, we're told that the length of the side A plus B is greater than the length of C. Use this to prove that cos of Y plus sine of Y is greater than 1. Alright, so just have a think about this now and attempt it. Okay, remember how we're saying you can pass this paper without getting a single correct answer. So you might be reading this think double Dutch. Jeez, I haven't seen this at all before. But just try and tease out a bit of an answer. Could you look and see, well, what is cos of Y? What is sine of Y? Could we go that way around answering it? Okay, so what is cos of Y? Right, cos is caught a herring. So first of all, we're going to label our sides. All right, so we're going to copy this here. Now I might change cos of Y plus sine of Y is greater than I'll get that in a second. All right, so what is cos of Y? Caught a herring. Right, well, it's a fraction. All right, so right, so it's a fraction, and what we fill in, all right, called a, which is a, all over herring h, all right, so add on to that sine. Well, again, I forgot what is sine of y. Sine is silly all, o, which is b. So b all over, no, this should be c, and this should also be c. All right, and then the two of those are insert symbol. Oh, give me a second to find this. Look for these. All right, so we got our greater than sign. So we're told that that is greater than 1. All right, now what I'm going to do here is, this is all over c, this is all over c, so I'm going to multiply everything that we've got here by c. Okay, so if I multiply and divide by c, they will cancel. So I'll be left with simply a here. All right. If I multiply and divide by c here, I'll be simply left with b. Insert symbol, greater than 1 by c is c. Look what I have. So I started with, I will finish this up here now, what we have it, is greater than our 1. Alright, so cos of y plus sine of y is greater than 1. That's what we're given. We have to prove that. So use the fact that a plus b is greater than c. Use this to prove that cos of y plus sine of y is greater than 1. This is what we were given. This is what we wanted to try and prove. So what is cos of y? Well, cos of y is the angle we're talking about. Cos caught adjacent all over hypotenuse. So a all over c. Sine of y, silly opposite all over hypotenuse. B all over c. And that was greater than 1. Alright, multiply left and right by c, you get a plus b is greater than c. So there it is, proved. Alright, so just study that, look at it, and I'm going to do a second way now also. Okay, so as I said, here's the second way that we could possibly have done this. All right, so our sides A, B, and C. All right, but just taking this, forgetting about everything else. If I just took this here, and well, if I look at it, that I want to end up with a 1 out here at the end. So how am I actually going to end up with a 1? What do I have to divide C by to end up getting a 1? Well, I know that if I divide C by C, so I'm getting a fraction of C all over C, well, that would simplify down to be 1. So if I divide C by C, I have to divide everything else by C. So we're going to take and do that. So dividing by C, first of all, we have A here, adding on to side B, divided by C. And we're told that is greater than 1. Yeah, that's what we're. So I haven't done it. All I've simply C divided by C. Bear with me now, this is the first time I've done this, so I'm a small bit slow. Right, so C divided by C. So that's what we have. I haven't done anything else. I've just simply divided all on the left and all on the right by C. Alright, so I'm going to leave A all over C. Well, if we look at it, what ratio have we got here? A all over C, if we think about it, A all over C. Well, A is the adjacent, C is the hypotenuse. Which trig ratio is that? Well, it is sine of the angle y, or cos, should I say. So it's cos of y plus, well, B all over C. B is the opposite. C is the hypotenuse. Silly old Harry. So it is sine of angle y. And that is greater than. And C all over C is 1. So here again we've now proved it a second way. Cos of y plus sine of y is greater than 1. And that's what we have. We started with, we're given a plus b, the lengths of those sides added together is greater than the length of c. All I simply done here was divided everything by c, because I would end up with a 1 out here. So I had to look at, well, what divides c by the simplify it to a 1? Well, c all over c will simplify down to be a 1. So there we have it. Alright? You could have started at the end and worked back, or started at the a plus b and worked forward. Either way. Alright, so here we're now moving on to 2018, the question 10, okay, to do with stairs. So Grace is putting in a set of stairs in her house. So give yourself time to read that, okay, but basically it's on about the staircase here is made up of a riser and a thread. So the riser is how high you lift your foot up. The thread is where you will actually place your foot on to move to the next step. All right. Public and private buildings have different sizes to guide and gauge them. All right. But we're told first of all, for part A, Grace's stairs will have an optimum size step for a private building. So private building and an optimum and an optimum. All right. Now we're told here that the stairs has to climb a vertical height of 2.1 meters, and we're asked to work out the horizontal distance or the length of the stairs. Okay, so basically what we are creating a right angled triangle. So we're going to just sketch. I've just inserted here, so we're sketching a right angled triangle. We know the height that the triangle has to climb, and that is 2.1 meters. All right, and we are then basically trying to find the value of the distance that the staircase, should I say, comes out from the wall or whatever it's up against. So basically we're going to call that x meters. Alright, so this is x meters, this is what we're trying to find. This is the vertical height that we know. We're then work out the horizontal length of the staircase, i.e. the sum of the threads. So we need to first of all figure out, well, how many steps high is this? Because we don't know the angle, or we don't know anything, so we need to work out how many steps is in this staircase, and that will allow us then to multiply that answer by the optimum length of a thread, and that will find us the x value in this case. So 2.1 meters, right? If we convert that figure, sorry, 1 second now. If we take and we convert that figure, bring this in if I can. There we go. Right, so 2.1 meters, if I convert that to centimeters, I'm going to end up with 210 centimeters. And if I divide that by the optimum height, right, which is 175 millimeters, or 17.5 centimeters, if I divide those two figures by each other, that will equal 12. Right? And if you don't believe me, we'll just go 210, divide that by 17.5, and that will give us 12. So 12 steps it will take to cover the distance of 2.1 meters in a vertical height, given that we're working with our optimum riser height. So we know now there's 12 steps. All right. So what we're going to have to do now is multiply 12 multiplied by the optimum size for a riser. So the optimum thread here is 250 millimeters. All right. So again, clear this. So we're going to have our optimum thread of 250 millimeters. We're multiplying that by our 12, and we're going to get 3,000 millimeters, or 3,000 millimeters. And we're asked to work out the length, and we're not told the value to give it in, right? But I'm going to change that from millimeters to meters. So 3 meters. Right? So for a vertical height of 2.1 meters, your stairs will come out a horizontal distance of 3 meters. All right. Happy enough? Part B. The angle of elevation of greatest stairs is marked with an angle A. Okay. Using trigonometry and without measuring, work out the size of the angle A. All right. So fairly straightforward in this. We're just going to have to use our trig ratios. So dealing with this triangle here again. So this is our angle here. This is our opposite side, hypotenuse, and adjacent. So we're using our adjacent and our opposite. So which of our trig values uses O and A? Well, it is tan. So insert text box. So it is tan of the angle A in this case, and that is equal to pulling off O, which is at 2.1, which is at 2.1 all over 3. Okay, using a tan inverse function. Obviously, that's the power is so tan inverse of our fraction 2.1 over 3, and that would equal the angle A. Okay, so flying over to our calculator. So if we go shift tan, that will give us a tan inverse function. And we'll go for a fraction of our 2.1 all over 3, in a bracket, and that will give us the nearest degree, 35 degrees. So 35 degrees is equal to the angle A. So the steepness of that staircase, should I say, is 35 degrees. Now, moving on. Write down the length of the thread and the length of the riser that will give maximum angle of elevation for a public building, and give your answer in millimeters. Alright, so write down the length of the thread and the length of the riser that will give the maximum angle of elevation for a public building. Give each answer in millimeters. So again, we're dealing with a right angle triangle. I'm just going to steal this one. Make it a bit smaller. Okay, and we'll format it, and I'm going to get rid of the fill. So there we have, basically, if we look back here to this slide here, right, the angle of elevation. So this angle A is what we're trying to make as big as possible. All right, so basically we want the maximum height to the minimum width, and that would allow for this angle A here to be as big as possible. So what is the maximum height? Now remember, if we look back, we're talking about here for a public building. So for a public building, right, the riser, what is the maximum size of the riser? Well, it's 180 millimeters. All right, so this value here of the riser has to be 180. So if we insert text box, I think I know where it is at this stage. So 180 millimeters. All right, go back here. So riser maximum public 180. The thread, if we look at where we're putting our foot, this is, we want this to be the smallest. All right, but if you look at public minimum, that's your minimum of 280. So go to the next slide. Thread 280. Right? So write down the length of the thread and the riser that will give the maximum angle of elevation in both cases. So we want the highest riser to the least amount of thread. And if you look back to here, then you had thread is where you put your foot, public building, minimum 280 millimeters, optimum is 300, but minimum, we're looking at the riser, the maximum is 180. So if you go for the max, rise, the min thread, that will allow that angle A there to be as big as possible. And if we look here, we're just asked to get the length. You don't even have to work out the angle, all right? So you don't even need to draw in that triangle if you don't want. So there, both your measurements here. Now, moving on, so question 11, all right? F is the angle in a right angle triangle, and cos of F is equal to 6 all over 11. By drawing a diagram of a right angle triangle, find the value of sine of F and give your answer in surd form. Okay, so first things first, we're going to draw a triangle. Put in our labeling. So this is always going to be the hypotenuse, right? Now, where are you putting your angle? Are you putting your angle down here? Or are you going to put your angle here? It doesn't matter. So I'm just going to keep things nice and simple, and we'll put our angle A down here. Obviously, then there's your angle, so this is the opposite side to it. So there's O, and there's your hypotenuse. Yeah, move the page, just want to move A. Right. So let's now fill in from what we're given. So the cos, well, we need to call this F, not A. So cos of F. Cos, so starting our silly old Harry. Cos a herring. So adjacent is 6. So we're going to put that in brackets. So A6, hypotenuse, in brackets, is 11. Yeah, and we don't know what that is. So cos a herring. We don't know what the opposite is. We're asked to write in or find the value of sine of F. So right away we start doing that. Next box. Sine. The angle of F is equal to the old O, which we'll call X because we don't know what it is. Insert a fraction. We'll call that an X. So silly all over 11. Okay, so there we have started off. So by drawing, we have to draw a diagonal right angle triangle. Find the value of sine of F. Alright, so and give your answer in third form. Alright, well, we don't know what that is yet. Okay, but can we figure out the value of that side? Oh, there, the opposite side. How can we work out that value of X? What are we dealing with? We have a right angle triangle. Do we know any way to work out the value of a third side in a right angle triangle when we have 2? Yes, there is. Pythagoras. So 121 is equal to x squared plus 36. So we're going to get 121 minus 36 is equal to x squared. Alright. So and then we're going to get the square root of the 121 minus the 36, and that's going to give us the value of x. Okay, so jumping over here to our calculator, we're going to go get the square root of 121 minus 36. That's going to give us the square root of 85. Okay, now, and we're asked to give our answer in third form. So we just leave our answer as the square root of 85. That's that part of that finished. Alright, so moving on now fairly quick of these because these are sort of easy enough. So 2017 paper 2 higher level. Alright, question 8. So A, we have to work out the value of the angle Y. Alright, so ignore the top triangle that's placed on it, we're just looking at the bottom triangle. So which of our three ratios will include our hypotenuse and our adjacent side? Okay, if you're struggling at this stage to label up your sides, pause the video, take your time and come back to us. But assuming that you were okay at labeling our sides, we've identified that 12 is our hypotenuse and 10 is the adjacent. So cos a herring is adjacent all over hypotenuse, so 10 all over 12. Okay, so if we now get the inverse cos function of that, so cos inverse of your fraction of 10 all over 12, that will equal the angle y. Okay, find that in our calculators, we're going to get shift cos inverse of our fraction of 10 all over 12. And that is equal to 33.55, and give your answer back one decimal place, and that's going to be 33.6. that's our angle y. Now, find the value of x and give your answer correct to the nearest decimal place. So we have got a right angle triangle. We know the length of the hypotenuse. We need to work out the sum of these other two sides. Now, again, nothing tricky in this. How would you work at this if you knew the value of x? How could we prove this is a right angle triangle if we knew the length of the three sides? You would use Pythagoras, and you would say that the square of the hypotenuse should be equal to the square of the other two sides added together. So let's work with that. So, delete all of this. So the hypotenuse to be squared. So 12 squared is 144. So that is equal to the sum of the other two sides to be squared. So x plus x, each of them squared, is going to give you 2x squared. Alright, so if we look at that, so x to be squared and x to be squared is 2x squared. Right? Just added those two together. Yeah? Now, dividing both sides by 2, I'm going to get, what am I saying? 72 is equal to x squared. Getting the square root of both sides, I'm going to get the square root of 72 will be equal to x. And going for our calculators, cancelling that, the square root of 72 is equal to 6 root 2, and we want to give our answer correct to do decimal places, so press your SD button, and we're going to go from correct to 2 decimal places, so we're looking at 0.49. Alright, so nothing with that, just using Pythagoras to work out the value of x. Alright, so question 12 here. The diagram on the right shows the right angle triangle with a hypotenuse length of 10 units. Okay, using trigonometry to find out the length of the side marked x and give your answer in surd form. Okay, so rather than doing out the solution, I'm just going to talk through it and do it on the calculators and trust that you're able to follow what I'm saying. So we've got the 90-degree angle. This is our hypotenuse. This is the angle in question, so this is the opposite side. So we have O and H, so we're talking about the trig ratio of sine. All right, so what is sine? At 60 degrees, that is equal to silly old Harry. All right, so opposite x all over 10. All right, so I'm going to multiply both sides by 10. So closing our bracket and multiply that by 10. And that will give us the answer of, or the value, should I say, of x. So the side x there is 5 root 3. And we're just going to print screen here, insert the colon V, crop. Give an answer in third form, which is 5 root 3. Okay. The diagram now shows below a regular hexagon, okay, with sides of length 10 units. The hexagon is divided into 6 equilateral triangles. Work out the area of this hexagon and give your answer in the form of a by the square root of 3. Okay, so just slow down, think about it. The hexagon, so I'm looking here at this second line, the hexagon is divided into 6 equilateral triangles. So what do we know about an equilateral triangle? Well, we know that all 3 angles are the same and all 3 sides are the same. So all the lengths of each of these 3 sides is equal. So we have to get the area of the bigger shape, which is a hexagon. But can you get the area of that triangle? Well, yes, you can. So if we go back here to our log tables here, and we can see that the area of a triangle, so if I know this angle C here, and I know the length of A and the length of B, then I can use that to work out the area. So the area of that triangle is equal to half AB sine C. So I'm going to use that. So half AB sine C. So insert your text box. So it's half, or 0.5, or 0.5, half AB, so remember multiplying, so half the length A, which is 10, bracket, the length, the length B, which is also length of half AB sine C, and C is 60 degrees. So half multiplied by 10 by 10 is 100, multiplied by sine of 60 degrees, 25 root 3. And we're asked to give our answer in the form of 8 square root of n. Alright, now remember, the area is equal to, what do we say again? It was 25, yeah? So 25 root, symbol, square root, 3. Now, that's the area of 1. How many of these such triangles have we? Well, we have 6 of them. So we need to multiply that by 6. And that's going to be here. But our answer is, and we want to give it in the form of A, so A is going to be 150. So that's going to give me 150 root 3. Okay, so 150 root 3, and that is our B. Right, okay, so our last homework exercise here, 2016, the higher level paper, question 8. Right, these are nice and easy, so we're just using our calculator, changing from degrees to decimal form. So I'm going to go 2 with our degrees, minutes, seconds button, 2 degrees, 43 minutes, and 5 seconds. All right, 5 seconds. And we're just going to press the equals buttons, and we'll see we've got back exactly what we put in. But if you just press your shift button again, it will give it to you in decimal form. All right, so we're going to correct the 2's in decimal places. It's just 2.73. Okay, so we're going to just print the screen there and insert it. So changing from one to the other is really simple. You're just putting in into your calculator. All right. Now if we go now for the second one, 3.14 equals for 30 degrees minutes seconds. We're going to get 3 minutes, 8 minutes and 24 seconds. Okay, so again, print screen, insert, crop it. So a couple of seconds. It's taking me longer to do it here, but you should be flying through it. So A and B, nice and easy. Degrees to degrees minutes seconds, degrees minutes seconds to decimal. All right. We want to here, we've got a triangle here with the angle A marked. So the diagram shows a right angle triangle with the angle A marked. Given that cos of A is equal to sine of A, show that this triangle must be isosceles. All right, so we need to prove that that triangle is isosceles. So we're going to use our trig ratios. So we're told or given that the cos of the angle A is equal to the sine of angle A. Well, what is cos and what is sine? So we're going to make two fractions. Okay, so two fractions. First being cos. So cot a herring. So it is adjacent. And I'm just going to go A for adjacent. That is all over your hypotenuse, H. Now we're told that that is equal to sine of the angle A. Well, what is sine? Sine, excuse me, old Harry. So O is opposite. So again, fraction. And we're going to go for up here. So O all over H. Okay. So we've got A over H is equal to O over H. Now, if I want to get rid of the denominator of H in the fraction, if I multiply both sides, left and right, by H, multiplying and dividing by H will cancel each other out. Multiplying and dividing by H on the right will also cancel each other out. So I will then simply be left with A is equal to O. So we have our adjacent side, we have our opposite side. The two of these are now equal, and this is our hypotenuse. So therefore, yes, this is an isosceles triangle. Simply proved by multiplying both sides by H. Let's see. A right angle triangle has the sides of length 7, 24, and 25. Find the size of the smallest angle in this triangle and give your answer correct to one decimal place. So we're going to first of all draw out a triangle. There's a triangle. Now, insert. Hypotenuse is always the longest side, which is our 25 centimeters. All right. This side here then is going to be our next longest side, which is our 24. So there's our 24. And our last side then is left at the bottom, which is the shortest side of 7. So all of them is I've drawn a right angle triangle and I've corresponded up three sides with the three measurements. The only one that I had to make sure of was the longest side was the hypotenuse. All right, 24 and 7 could have gone anywhere, but obviously you want to do it to scale. So we want to find the measure of the smallest angle. Now, I know the bottom angle here is 90. And just looking at that angle there and that angle here, well, this angle here is smaller than this. So I want to find this angle here. So this is the angle that I'm going to be talking about in the question. All right. So we have all three lengths. I can use any of my three trig ratios here. I'm just going to go ahead and go for sine. Okay. So I'll just move this over here. So sine of the angle. So sine of the angle, we'll call it x. Sine of the angle x is equal to, so silly old opposite. Well, if this is my angle up here, well, this side down here, the opposite. So it'll be a fraction here with 7 as the numerator. So 7 as our numerator. Harry H 25 our hypotenuse. So that is our ratio there. If we want to find x, I can get the inverse of this function here, or fraction should I say. So sine inverse of fraction 7 all over 25. Raised the closest one decimal place is going to be 16.3 degrees. So x and so is equal to 16.3 degrees. And that's solved. And again, if you look, you would have been very, very lucky to get that question there. I know it's gone back a few years, but degrees, minutes, seconds on your calculator, 1, 2, 3, working out that this is an isosceles triangle. All you had to do was multiply both sides by h once you wrote your trig values and what they were, and working out the size of an angle. Very, very straightforward, very easy. Okay, so that is our homework exercise all done, albeit a bit longer maybe, but you can skip through to the relevant section that you might be found a bit of difficulty with, and drop me a message on Google Classroom or that if you've any concerns or are unsure about anything on trigonometry. So that is us done with trigonometry basically, unless you need extra work or that. So you shout to me what you're thinking, and we'll be looking at moving on and doing a few new stuff later. Okay, so over and out.